Hi, everyone. So welcome to this webinars. It's going to be talking about Spring and Java. So I guess everybody's sort of a JVM person here. My name is Gil. And like I said, I'm going to talk about this, Java and Spring tips. People are still going to come in, so that's okay. I'm going to talk slowly until we actually get things going. This session, I'm going to talk about this also and remind people as we go along is bits of pieces of a whole workshop I'm doing. So if you want to learn about this, write your name in the chat window. So when a course comes out, we'll be able to call you. So if you're interested, we're going to do that. A bit about myself. My name is Gil, and I'm a consultant and a trainer. And I'm also the author of 2 books, Everyday Unit Testing, Everyday Spring Testing. I do all kinds of courses. I also do some kind of courses, but some witches have been able to lift them. Mostly I talk about testing, TDD, clean code, and witchcraft. That works as well. You can learn more about what I do at Everyday Unit Testing, which is the site of the books, or testingguild.com, which will take you exactly there as well. I also sometimes visit Twitter, and that's basically it. If you have any questions, please write them in the Q&A pane. I'll try to get to them as we're going at the end, unless there's something very emergency like, right? If your house is on fire, please write it very safely in the chat window so I can actually see that. Other than that, like I said, doing all kinds of courses around all these things, including Java and Spring testing, which I'm going to talk about today. If you want to know more, write your name in the chat window as well, or contact me at gil@testability.com, or my business manager Tal at testability.com as well. Beware of bugs, sometimes they get very big. At the end of the session, for the people who are going to be here, I'm going to raffle 1 or 2 books. They have a unit testing kind. So stay. Why not? Other than that, let's talk about Java. I'm guessing most of the people who come here are Java people, and most people who are Java people know what Spring is. Something springy. There was some kind of evolution over the last 25 years. When Java came out, the vision was write once, run everywhere. They kind of achieved this vision ultimately, but in order to do that, they had to create all kinds of supporting code and libraries and so on. This is how Spring actually started. It started out as a framework for dependency injection and grew a lot since there. And as it grew a lot, people had the same problem again. How do I write something from scratch? Because code was all over the place. And therefore, Spring Boot tried to put some order into this and make it easy to use. And it also made it easy to test. So we'll talk about a few things that Spring Boot brings to the table. It's bits of pieces, like I said. It's going to be like 10 tips about all these kind of things, and not just the testing features themselves. Going to talk about that. Spring is groovy. Because it makes things easier to run. It has a lot of power inside it that help you write applications very quickly. So you can concentrate on your own code and all the things that Spring takes care of, and that's cool. But we need to remember that if you write the code, we want to actually test it. So Spring actually, like I said, started as a dependency injection framework, which kind of said, well, if we can inject stuff in different places, separating creation other than the use of the objects. We can do these things easier, we can do things with more flexibility. And the cool thing is, well, we can mock stuff, we can replace stuff. As we're working to test our code, we can do these things as well. But like I said, Spring got, let's call it, bloated. So it brings a lot on the table, and when we're talking about testing, we need to actually think about what we're trying to do and what we're trying to achieve, not just use these features as is, because they actually, if we want, bad things will happen. And it's not just for, like I said, using Spring. It's not just for the production code, also for the testing code. And one final warning, it really isn't just about the tools. So we get great tools. Spring is a great tool. Spring Boot is a great tool. Brings a lot to the table. And the more we know about what it brings to the table, we can use it better and more effectively. However, it's not enough. First of all, we need to understand how Spring works. And I'll show you examples of how sometimes we have assumptions of how Spring works, and it's just not, doesn't work like that. And has an effect of how we test. A lot of it is how to write testable code, and mention what testable is. We kind of assume what testable code is, but it's not always like that. Something that I always say, simple code is easier to test. We'll talk about some kind of principles today that makes it both simple and testable. And like I said, always go back to understand how things are working and learn the tools in details, because like that, you'll write code that is kind of fit the tools and therefore fit the testing. So I'm not writing the next book, but tests or testability are always on my mind, and it should be on yours as well. So obviously you're here to hear about that. Learn about how things work, and I'm going to stop here. The main thing about testability is that there's no such thing really as a untestable code. Everything is testable, giving enough resources and time and effort. If it's becoming expensive to write tests, to prepare tests, it probably means we won't do it. We'll prioritize something else, do something else in our time, because we don't have all the time in the world. And that means we'll kind of deprioritize testing. And if we are really serious about testing the stuff, we need to go back to simplicity and learn about this stuff in order to give ourselves a chance to test it better and don't lose it on the way. If we don't do that, kind of gambling on quality, and I'm sure nobody wants that. So, Mr. Gambler Cat, I'm out. Not the last time I'm going to mention it. There's a whole course I'm doing about Spring and Spring Boot testing. If you're interested, give us a hit on the chat window, and let's talk about some tips. I gathered that these tips around several topics, and I'm going to start with before we can actually start testing, writing tests. And how should we prepare for writing tests? So the first tip is about verification tests. Verification tests are kind of a weird way to test things, but they're not. They're kind of a type of tests, not like a unit test or a functional test, something else. Verification tests are concentrated and focused about checking that whether things are ready to run the real tests. Verification tests tell us that things are okay and we can trust the environment when we start running the test. So we won't run things and everything will fail because we don't have the right JDK here. So I want to show you, where's my, yeah. So whenever you start, you create a test with Spring Boot Initializer, for example, you get this kind of test called context loads. It's a freebie. And you look at it and say, well, this is probably a placeholder, but it's not. It's a real test. And what it tests is that Spring actually loads. So I'm going to run this. This test can create for you when you create something with Spring Initializer. And this one actually fails. And you see it loads Spring, and the name gives you an idea of what it's trying to do. It's trying to load the context, the application context, Spring. And and basically you see that application run fails and bin definition store exception, blah, 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 blah. Lots of errors appear here on this very empty, seemingly empty test. But what it tells you when it passes, that Spring loads correctly. And that means that it finds all the definitions for the bins. There are no conflicting bins, all kinds of things that are ready for you to start running your tests. And that is very important. I use this all the time, not just in demos. So how do I use that? First of all, this empty test, I always keep it, because when I try playing with my tests, moving bins around and renaming things, I want to make sure that things are still working. And that's very important. Because otherwise I will get very strange failures on the test and try to debug them. Well, they're not even started running yet. So this is the one thing that I keep all the time. But I do all kinds of verification tests elsewhere. So when I do some API tests, for example, with mock MVC, which I'm going to talk about at the end, I check all the time that the mock MVC loaded correctly and the controller will work correctly. Things that I'm interested, loaded correctly. If I know this test works correctly and just loading stuff it works, that means I can actually focus on the other test, all the functional tests. So verification tests, very important to learn about what they are and use them, that this is not a placeholder, this is a real test. Okay, let's go on to number 2. And this one's about test organization. So whenever you start writing tests, I'm sure most of you have written tests before, it's going to be 1 or 2, but then very quickly you get to hundreds and thousands of tests. And therefore you need some kind of method of organization. I'm going to show you an example. It's not the example of what you should do, but you'll see that there's some method to the madness. So let's take a look. So under the test, usually when you create like a project, you get a test Java folder, and under E02, that's my example 2, I've created some kind of organization. So for API tests and maybe BDD tests and maybe end-to-end, and it could be like features themselves, like UI or workflow, that I can put things there. And the most important thing is that when people in the team going to add tests, they know where to go. So there has to be some kind of method, some kind of organization that you actually want to follow in the team, create some kind of shared practice. I do want to mention, though, a couple of things. Spare a very good separate place for unit tests. Why? If I run this unit test, it's an empty one, I know, but it's good for the demo. It's going to run, everything's okay, and you notice that it doesn't load Spring, which is good because I want it as a unit test. And if we kind of start writing unit tests inside Spring test, they actually look like this, with a Spring Boot test on them or whatever test. What happens is that if this one does load Spring, and people who have worked with Spring before know that at the moment you have like 3, 4, 5 beans, just getting to running the tests takes very long. So if you want to run unit tests very quickly, keep them separate from the Spring test. Now, there's something called Spring unit test. Now, there isn't really, but in the Spring documentation, you'll see these kind of things. Like if you have something like with AutoWire that's going to load a bin into that, and you just create it, it looks like a unit tests, but it doesn't because it loads screen. Whatever needs Spring is already an integration test. So what Spring calls Spring unit tests are actually integration tests, and they're slow. Even they're checking one class or one bin, I don't know what they're doing and what they call it. It's an integration test, whatever load integration into that, and that could be a very heavy load to lift. So separate unit tests from everything else and check out if some kind of a method of organization. Always look out for what takes the bigger part of the time when you're running, because this is how you might want to separate stuff. If you want to run tests more, that means that you want feedback as quickly as possible, and therefore things that run for too long will make you not run these things too long. So do the separation. Okay. Yeah. Getting there. Final thing I'm going to talk about just preparation is logs. And I want to show you something. Yeah, so I'm going to show you an example with my verification test. So I'm going to run this now, and you can see it, how things are going under there. And apart from the Gradle stuff, you see that Spring loads and so shows me the error. And that's cool, because if something fails, I want to find this error. So what I'm going to show you is what I did in order to do that, because that's not the default way. So under test resources, I have a logback test XML. It depends on whatever logging framework you're using. This example shows log XML. And you see that the things that I mentioned here and things that are Spring really related are on level error. That means that without it's not the default logging level of Spring. What I'm going to do now is just going to put the rest of this stuff in comment just for my demo purpose. And I'm going to run my thing again. And you see that it already starts writing stuff that is irrelevant just because the default level of logging is warning or info. And obviously the errors are there, which is good. But if you start trying to find when an error happens, you're going to waste some time. So why do that? All the things that you need, probably most of the time at an info level, are irrelevant and will just create noise for you. So make sure that you clean up the logs, whatever your method is, and you'll save yourself a lot of time, because when you're trying to find problems in the terminal window or the log window, it's going to be a lot of noise there, especially if you're running like not a very stringy demo here, but a full application with a lot of beans loading and a lot of resources loading. You'll see a lot of noise there, and you don't want that. Clean it up. Clean it up. Yeah. So goodbye to the log lady. And I want to talk about design which leads to testability. How should I write code that will make me use Spring and Spring testing effectively? So that's about the production code, not about the tests. First thing doesn't involve code. Testability And therefore, the ability to write tests doesn't come from thin air. We have to think about it all the time. And even if we're using Spring as a tool, it doesn't make things testable. Remember, testability is not about ability to test a binary version. Can I do it? You probably can. Will you do it? It depends on how easy and simple it is to do. So unless you're thinking about this all the time, even at night, on the pillow, the more you think about it, your code will become like that. And I'm going to show you a couple of examples of making things more testable and how. The first one would be about talking about thin fed controllers. Now, most people who have worked with Spring know that Spring allows you to write REST APIs very easily. By the way, next webinar is going to be about testing web REST APIs. But apart from that, we write code in order to do that, and controllers like are the entry point of where you write code in order to do that. So let's take a look at the code like that and what's the difference between this. Again, remember, I'm talking about production code, whether not the test code, because I want to show you how the way we write code actually is different. So this will be like a very simple design. We have a controller, a REST controller, and he has an auto wiring of the logic. And you see there's some kind of validation here, and if everything's okay, whatever, it goes into the logic, and otherwise creates a new item. The logic itself kind of goes, it embeds the repository, goes to the database, gets it, gets the item by ID. Item is not really important for our story. So what is a fed controller? A controller that has some kind of logic in it, like this. And what's the problem with that? Usually there's no real problem, but a few small problems. First thing is that if I want to check this kind of logic, I have to raise the controller. Maybe it needs all kinds of setup and dependencies just to run, like the logic itself. We don't need it for the isValid method. Second, well, it depends, but it could be like a private method, which makes it hard to test. And in any event, we'd like to have the logic unit testable and everything that is like that unit testable. Basically, the solution is the fed controller is the anti-pattern. The pattern is to create something that is a thin controller. Thin controller looks like this. It just passes everything, delegates everything into the logic, and the logic looks like this. And this is a lot. First of all, it doesn't carry the baggage of the controller, but more than that, it just carries the logic baggage, because logic could be one bean, well, the controller requires like 30. So setting this up as a Spring unit test or real unit test, the baggage is lower. That means that the setup is less expensive. Probably you'll do it better. So the pattern is basically keep logic inside where it needs to be, not in the controller level, not at the adapter level. I'm going to talk about adapters soon, but if you know about ports and adapters or hexagonal architecture, same principles. Keep the controller logicless, so you don't need it and all its baggage and whatever it loads in order to test it. You can do that apart from that with API testing as well, but the logic itself you probably want to unit test. Okay, so that's thin controllers. And I want to talk about something completely different with like caching, because it's important to talk about caching. Plus, I like Johnny Cash. So what's the deal? Caching is one of the things that you get, I wouldn't say for free, but again, a lot of things that Spring gives you that you don't need to do by yourself. So basically, you implement an API, you say it's cacheable, and what happens is that the first time you go in there, it gets to get by ID, invokes the code, and it creates a small cache by a cache manager. You provide it to you, and it keeps the answers there. So if a second request comes there with the same parameters, it looks at the cache first, and instead of going into the database, it returns the answer. Which, in terms of production code, that's very cool. It's very efficient. Caching is done basically to improve performance, and that's cool because we want better performance. With testing, we want something else. That is control about what we're doing. And that means that if you don't know which tests run first and what they do, that means that you don't have control over the cache. You don't know when it actually went into the code, when it didn't, when it cleaned the cache. So that could be like a production setting or some kind of things that you don't have control about. And in scenarios that you actually want to test, you need this knowledge. And that means, again, something I said in other webinars as well, you need to understand if this line exists here. Now, mostly this is not a problem. Why? Because most of the time you write the code. You're the developer. We're talking about the Spring developers here. That's cool. However, if you're doing like API testing from Postman or whatever, you don't have access to that code. It looks like a complete black box from the outside, and therefore you don't know what's going on here. And specifically, if something went wrong, you don't know at what point it went wrong. For caching, after caching, you need to do a lot of digging. So that's not about maybe you writing integration tests, but it is about the testers doing integration tests, and they want to not waste their time as well. So they need some kind of access to understand when caching is done. They also need something that you may not give them, which is something like this. This is an API. It doesn't really matter what it does, but it has cache evict on it. It tells basically Spring, clean up your cache for item, not for the other stuff. So this would be something that you may not want to expose to real users, but you might need to control that in terms of API testing. So you might want to give an API like this that does the clearing for you, again, for the purpose of controlling the tests. So first, it's not like don't use cache. Use cache, but first of all, be aware that how things are working, and when you're testing stuff, it may not be the scenario that you actually envisioned when you're writing integration tests. You need to be in control, and other people who run integration or API tests need to be in control. And that means that you may need to give them some kind of leverage of how to clear the cache or fill it depending on their scenario, because this is what makes testability. If we don't have this, if we don't have the clear method right now, that means that I'm kind of floating and I don't know what kind of scenario I'm actually running. And it might be, I'm assuming it was something, but I'm not running the same thing I envisioned, which is not good. So think about caching when you're doing it. Next couple of tips, I'm going to talk about mocking, which is very cool. Mocking we usually do at, we start talking about unit tests, and obviously this is where we learn about mocking and Mockito. Mocking in Spring kind of brings up interesting stuff. There are different scenarios. I'm going to mention a couple. And the first one is about where do I inject the mocks, because it has an important cost to it. changes and so on. So I want to show an example. I'm going to leave off from the where did we go last time? So this is the main. Yeah. So last time we were here, let me close everything up so we can actually look at the right code. So we left at the, we delegated things from the controller to the logic. Excellent. But you see that our logic still has the auto-wired item repository, which by itself is really not a problem. Problem starts when you actually want to test the logic. Now, what happens is that if you just create new logic outside Spring, that means that the item repository is null. And that's a problem because we actually want to run it with the item repository. So we need a way to inject it. The way it's written right now, there's no way to inject it because there is a way, but we can't really inject something that is private. I need to do some kind of modification, and I can make this field public. I'd create a setter, can do all kinds of things, but the way it's written like that, which is kind of Spring ready, but not unit test ready, makes a problem for me. So I'd rather write things in a way that will make things easier for me to test. So the test for that means that I need to create, I need to test the logic with a controller. So how does it look like? This is a Spring Boot test. Spring Boot test require configuration. The configuration create a controller and the logic. If I want to mock the item repository, I'll create a bin called item repository, mock it here using Mockito, return it, and Bob's your uncle. And everything's okay. Let's see how it looks on the unit testable version. In the unit testable version, control still looks the same. It's still embedding the logic because it doesn't create the logic. The configuration creates it. So it looks the same, but I changed the logic to have a constructor that injects the item repository directly. It's no longer auto-wired. How does it look like from the other side, from the test side? Other than that, everything's the same thing. So the test looks completely the same for the controller, but the configuration basically, again, looks the same, right? But now I can write a logic test that injects the mocks directly into the constructor. So I haven't abdicated the way, the possibility of testing the controller as a unit, a Spring unit, really. But now I have a way to test the logic without Spring because I kind of clean it up from any auto-wired things. Now, this is a very simple example, okay? And I had to clean up one thing and one auto-wired thing. Most of real-world applications don't look like that. The Spring gives us a lot of power to inject bins across different layers whenever we want to. This is great power, but it creates a lot of dependencies. And when we have this dependency, we have to supply them. So we need kind of way to actually do that. So unless we have some kind of pattern of working like that, we're going to get stuck. Now, we need to think about this thing. This is the testability, thinking about testability all the time. How are we going to do it? Where are we going to use mocks and so on? So we need to think about this thing. It's not like a clean everything. But in terms of clean architecture principles, this is like a good principle. Everything inside the unit testable world should not know about Spring. Everything else, the wrappers can inject things from the outside in, and then we have the ability to test everything in the adapter layer, the controller level, and the other side as well. talk about that in a minute. But everything inside it, where the logic is, and we actually want to unit test and run quickly, we're going to actually do that. We need to make sure that things are working like that. The inject mocks, there's a comment in the chat window, inject mocks, which is a Mockito thing. It's not a Spring thing, and you can use that as well, but it's not, you need to create a better pattern that is not confusing. So I suggest, like, regardless whether you're using inject mocks or not, write it in a way that makes sense to everyone, that this is Spring, this is not, this is unit testable stuff. You can use inject mocks. I kind of stopped using them. I found that it's easier for me to use explicit mocking with Mockito. It makes more sense to me, so I can look at things and just saying, this is, I have control over that, which kind of leads me to the right, to the next thing. And the next thing is understanding the mock life cycle. So I'm going to give you a very, very quick crash course with examples of how mocking can go wrong in Spring. I talk a lot about this in the course, but this is going to be like 5 minutes. So let's take a look. Again, I'm going to close everything so I don't get confused. Close this, yeah. So this is a very simple example. I'm going to use the mock repository. Remember, this is just a repository, it's an interface. And I'm using the repository config to create it. So that's just a mock. There's and something about AutoWire being completely wrong. I'm not sure, but if you, as Serge Karpov said, that otherwise error-prone approach, it should not be used for code at all. If you follow what I said, this is basically what I'm saying. The thing is that it's so easy to use and misuse it. Unless you have a team that actually follows these practices, you won't need this webinar. But most code that I've seen does not, people don't follow that. They use AutoWire everywhere. Mocking. So like I said, I'm creating a bean of a mock here. And here's the first example. So I've took two tests here called first test and second test. I'm injecting the mock here, and you see the first test calls the method and verifies that it was called, and the second one doesn't call it and verifies that it wasn't called. Looking at it, both tests should pass. However, surprise, surprise, and a lot of patience, the second one fails. It fails because it tells you never wanted but invoked, so the method was called. How is that possible? Well, the way Spring works is called a singleton. Beans are a default way of injection is singleton. They are created once and are cached. Now, usually that's not a problem, especially when you're setting behavior. Every test will start from where do you start setting behavior. Verification, however, no, they continue the count. So what happens is that this one's created once. When verify calls, this test gets run, the count on find by ID is raised by 1. So this is why this one passes. However, nobody resets this, and we're still using the same object. So when we're using Mockito.verify never, it fails because it already got called. So we need to understand how Spring works in order to use mocking correctly. So what do we do about this? Like I said, a crash course. You can do a couple of things. First of all, you can use Mockito.reset. Resets behavior. It also resets the count. So basically, that works for these two tests. I'm going to run it. You'll see that it works. Both tests will pass. See, everything works. Excellent. Until, remember, it's still a singleton. If it's embedded in other tests as well, you need to reset in every test. But if you forget in one test to reset, it's going to be a lot of surprises there. So reset works, but you need to either start using other beans instances or remember to put reset everywhere. Trying to remember everything doesn't work. So Spring has something called prototype beans. You can see that this time we put a scope prototype. Scope prototype means that every time you embed it, it creates a new instance. So a prototype test that uses this configuration will work without the reset. By the way, why does this work? Basically, we're running the same thing. It's injected once, right? Wrong. JUnit creates an instance of the test class twice, once for each test. So we need to understand how JUnit works to understand how JUnit and Spring work together. So that means two instances. That means two different instances of the item repository. This worked so well that Spring created something called a mock bean. Maybe some of you know. It's called a mock bean. And basically, if you do a mock bean, it's created just for this test class. And you'll see that it doesn't require any configuration. And the good practice is that it's created here, and you set behavior as part of a setup or each method differently. And this too works. And this creates like the whole, it's basically the same as prototype, but without a single configuration. You need to use mock beans whenever you use. That was a very small and very short crash course about mocking in Spring. It's a whole world. We're kind of getting late, so let's talk about a few more tips. Adapters. We already talked about adapters when we talked about controllers. Controller is an adapter. It changes an interface. So if you have the logic and it exposes a REST API by the controller, right? But there's the other side of the equation. So up until now, what we had was the unit testable version, remember, controller and the logic, which now gets injected with the item repository, the constructor. And the item repository, it's a JPA interface. So when Spring runs its magic, it identifies this as a repository. It creates a full implementation of an item repository, which is cool. But if we look at this, let's look at the logic. If we look at the interface, you'll see all find all by ID kind of things that if we want to mock these kind of things, we need to create all kinds of things that we may not want. Plus, creating an adapter gives us a chance to create a simple interface. But I'm going to show you an example of what you can do with working an adapter, which is not a JPA interface. So what I'm going to do is basically I'm going to say that item repository, the logic doesn't work with the item repository directly. It works with a repository adapter. A repository adapter is an interface, a simpler interface, maybe more readable. Doesn't matter this, but it could be. But it exposes a different interface other than the item repository, which kinds of maybe creates a lot of things that we don't want. And let's say this, usually the repository works with a SQL adapter. So basically I'm just delegating that the item repository injection into the SQL adapter and working with the SQL JPA regular stuff, just inserted a layer there. Basically, I didn't do anything except a bit of code. But now I can do a bit more than that, because now with the configuration, just create a controller and a logic, but they can create a map adapter, which is not a production code thing, it's a test code thing. It's here. And this my implementation is just a very simple map or a hash map that says if you call this with this parameter, you'll return this thing. So it's not a Mockito mock, it's a manual mock with some bit of complexity or flexibility, depends on how you look at it. And now with this, I can actually test the controller, the logic itself as well, but this is more about testing the controller a bit with the adapter. So if I check the controller, I see that get by ID with an empty item ID, 0, it brings up a null, but the get by ID with a non-empty item gives back with a null. So playing with interfaces, as we have also in our chat, interface-based things works. Java is not like, this is something that Java has more than other languages. And by having things virtual by default, make them mockable, easier with Mockito. But interface-based is always better because you can actually separate things with better implementations or flexible implementations. It's not about better. So having the flexibility to replace stuff easily with more options, and using the adapters gives you a better way to stuff whatever you want and a simpler interface. So think about using adapters on both ends of the APIs, the controller level, and where your logic starts talking to other resources as well. Final thing I want to mention about API testing is that mockMVC is your friend. If you don't know about mockMVC, it's like that. Usually when we test APIs, we kind of work against running application, and we can use either REST client or web client, depending on where you are on the timeline, and both work. But this requires a working application. A working application requires you lift everything, and everything's going to run by the time you start calling it with APIs. MockMVC is something that you get with Spring Boot, which makes life a lot easier because it doesn't require you to have a running system. It just loads the things in process. So for example, the last version that we have, controller up to a repository adapter, close everything so I don't get confused. So you get a controller test. This is one way to use mockMVC. This time I'm not auto wiring it, which is, you can do that, and you can enable automatic mockMVC configuration. Here I'm just creating it with mockMVC builders, specifying the controller that I want to load. Just load with standalone setup a single controller. Don't need to load the entire application. Just the controller, and therefore only the dependencies that it needs. Imagine your application full of auto wiring stuff like hundreds of beans. You need to supply them in order to run the test, to start running the test. So mockMVC allows you to say, I'm testing this controller, and this controller loads into my process, so it runs quickly. It's isolated from everything. It shuts down the minute the test stops running. So everything, what you need is going to be there, and it comes with cool flowing interface. Fluent interface looks like this. mockMVC perform a get or a post or an update, the URL that you want, whatever you want to add params, content, whatever things you do with the header and the body, you can provide it here. This is very simple because it's a get, it doesn't have anybody. And expect status could be like okay or internal error, so whatever you want to do it. It's like an assert, and you can check what it returns. This is the body that it returns, and you can do this with two APIs, like this, and you could get the string and use object mapper. I'm using Jackson for XML JSON serialization to get the item back and do asserts on that. So we use the item as a description, so I can do validation on that. And that's very cool. Like I said, you don't need a full system to run. It just loads when you start running the test, ends when it shutdowns when you your tests completed running. No footprint left, no garbage left, no databases to lift up or down. You supply whatever is needed for your context only. But I'm going to give you one more thing because I don't like the way this test is written. And the other tip I have for you is always review the tests. And not you, somebody else's. And it could be a cat, it could be a duck, but preferably a human that can give you feedback. So if our cat doesn't like this, tests can be refactored to look a bit better. Just extract things into methods and things become a lot easier to read because you leave out all the noise. Remember, mock MVC, like so many things in Spring and other frameworks, it's supposed to be generic. It's supposed to be not application specific. It's supposed to work with everything. And therefore, it has a generic interface. But our tests should not be generic. They should be application specific. So it should read to us like we're using our applications, our part of the application. Therefore, the generic interface can go so far in terms of readability. It's great in terms of usability and functionality, but not in terms of readability. Always read, always refactor, always get someone to review your tests. So that was like tips on Spring, and now that we have these tips, you can actually get ready to. Okay, we're ready for winter, but yeah, go when you start going to work tomorrow or even today, if you're lucky. Think about these things. Think about testability. Understand how Spring works. Try to think what you want to achieve in terms of testing, and stability always on your mind. Learn the tools, learn how Spring and the other stuff works, learn how they impact the test that you're writing. And think about how writing the code helps you write tests more easily, because that's what we actually want. We want code that works. Only way to do that is by tests proving that the code works. And in order to do that, we need simpler code. So these things always go together and mesh together. And that's all I have for you today. So any tips of testing with Spring plus Kafka? Okay, so tips about Spring with Kafka. So we need to think about what we want to achieve, what we're trying to test. So Kafka is a good way to do messaging, and it works very well. And it depends on what you actually want to check. If you want to check the system, so if things are working in terms of accepting the events and sending them over, you're going to set up a system that loads Kafka and whatever you need in order to test it. But if you want to check your code, that means you're going to start limiting your system. It's not an either or thing, but it could be like a different set of tests that you want to check. That you could be like do a unit testing, that the logic itself processes the events directly, and then that you can just mock Kafka and make sure that events are sent correctly. It depends on what you actually want to do that. So it starts with actually thinking how I'm going to test, maybe in different levels, maybe in different objects. What is the functionality that I'm actually interested in working? Again, taking into account that Kafka is probably working okay. If you're interested for something completely different, like how do we work in load, then you actually need to set up everything and then like bomb it with events and see how things are working in terms of that. If you're interested in the parallel processing of things, you might want to set up your system in order to challenge it in a way that it does not a synchronic way, but an async way. So you need to start thinking about what am I interested in, and therefore how to set the system. Emery asks, I was wondering what is the best way of testing production database for you? Well, that's not a good question. Same answer as before. What are you interested in? If you want to see how a production level database works, without your system, without your software, get a copy of it and test it there. Sometimes it's possible, sometimes it's not possible. It works with a client who have a mainframe, like a COBOL mainframe, and it's not possible to get like a copy of it. And it's a bank, they have to sanitize data first and so on. So try to understand what you want from it at the beginning, so we can set it up in terms of environment, what you need. You can mock the database, like the guys with the mainframe. What they did is they used wiremock in order to record things on the staging area, and then in their integration test, they mocked the calls using wiremock, so they didn't need the mainframe, but they needed a staging area where they can actually record these things. So it started with what you actually are after and what you want to test. So I know that's not a good answer, but like I said, it's not a good kind of question. So yeah, we need to be a bit more specific about what we're after. So try to figure that one, and then set the environment and the tests around that. Okay, so more questions? I claim that not everything can be TDD, meaning testing before writing, since the results might be not be expected. Do you agree? You can TDD everything, but automated tests require you to know what you're expecting. Everything else is not expected, therefore you cannot write an assert for that. Everything that you can't really automate, not because it's hard, it could be hard, but everything that you don't know what the expected result is because it's an algorithm, it could be an edge case, you don't have a requirement for that. Something like even load. How many users do we support? We don't know. Okay, so unless it's spec'd out, you can't really automate that. You can do statistic testing. It could work like 75% of the time, but that's a spec. So you can automate everything that you have something that you can specify a pass-fail criteria. Can it be done with TDD? Yes. Can it be done well with TDD? Not always. If you try to do like quicksort in TDD, at some point you get to the point where, like, I've used all the small examples and I kind of assume that it works for everything. Does it? I don't know. So what happens when you give a quicksort with like an array of a billion and trillion stuff? Does TDD help with that? I don't know, because it's not in the code, right? It's in our case in Java. Will Java accept this kind of thing? So it's not like TDD you can do everything. But first you need to understand what you're actually developing. What is the spec? If you know what is the spec, you need to check if this is your code that does this or somebody else's, like the JVM or a gateway server that doesn't even get to your code in that. So it's not about, it's going back to understanding where is our code. TDD is centered about the code that we write. That's why it goes more well with unit tests, although you can check out the webinar I did from back end about TDD and API. You need to understand what you're actually testing, and TDD is a development method, rather than testing. What you have as leftovers are the tests. How about, okay. Any more questions? How does one test that code that has been vaccinated? try to infect it and see what the result is? I guess so. I don't understand the question about the code that has been vaccinated. Was it COVID vaccinated? Does it have a booster? Mutation testing. Yeah, that's a good one. You know what mutation testing? Maybe I should do a webinar about mutation testing. Mutation testing about changing the code to see if it still passes the test. It's a cool method. Injected. Well, I'm not sure, like Delta variant. Yeah, the kind, yeah. So it was like a COVID joke. So thank you everyone for coming. Like I said, next time is going to be about API testing. So that's for every language in the universe, as long as it is a REST API stuff. So thanks for everyone for coming. Be in touch. Follow us on social media. Where is it? Yeah, it doesn't say so, but I have an Instagram account now that has all the memes coming up there. So if you, some strange reason, like the memes, follow that as well. Thanks for coming. Have a good night, evening, morning, rest of the day, rest of the week, and we'll see you next time. Bye-bye. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.